Hey students, welcome back to my channel. So today we will starting with a new chapter, motion in one dimension. It is in class 9th ICSE syllabus, but I am making this video for each and every student. Yeah, whether the students are in West Bengal board or CBSC, whatever they are in, or any other state boards, it will help them a lot. If their medium is in English. So this chapter is motion in one dimension. This chapter comprises of mainly the rectilinear not rectilinear, one dimensional motion, the equations of motions. So before we start, we have to introduce the scale of quantities. Then we will learn about the distance and displacement, then speed, velocity, acceleration, then the equations of motions, and there will be lots of numerical which will be coming in your class 9 examination, as well as this chapter, if someone strengthen this chapter, it will help them a lot in class 11. And I have also taught some 11 concepts, so that your conceptual clarity is so that you get a conceptual clarity. So let's start. Quantity is of two types. For the elementary level, there are other tensile quantities, other quantities also, but for now we will learn about the scalar quantity and vector quantity. Scalar quantity is all about unit and numerical value, but in vector quantity it comprises of the unit, numerical, and their direction also. The direction part is extra. So scalar quantity is like 10 kilogram, 10 meter, 100 degree Celsius, like that. But in vector quantities there is a direction. Like I say, I walked 10 meters, but in this is scalar quantities 10 meter, but in which direction? I walked 10 meters in north direction, northwest direction, in any direction. That quantity will be vector quantity. See, here I cap, j cap, and k cap is like I cap is in this direction. J cap is, you can say, j cap is north. Sorry for my handwriting. North. I cap is east, and k cap is pointing outwards, means in this direction, the pen direction. So basically this is j cap, this is I cap, and this is k cap. These are just directions to make you understand the concept of vector. So next topic is rest and motion. A body is said to be in rest if it doesn't change its position with respect to its immediate surrounding. See, let it understand by this example. The pen is resting on this copy. So according to this statement, this pen is at rest with respect to the copy or me, because I am sitting on the same bed, and it is also in rest. Rest or motion is relative terms. See, if one person is running with some velocity or speed, and the same another person is running with the same speed, then one, for this person, that person is at rest because both are moving with the same velocity or speed. So these are example which are a little bit advanced part, but for now you you should have a conceptual clarity that the pen is resting on this copy, so the pen is at rest with respect to this copy. So motion is same the it if it changes its position with respect to its immediate surrounding. So see, I have an example. Every this pen is at rest with respect to the copy. Is it at rest with respect to the earth? That's the question, because the earth is continuously rotating. So if we see that nothing is at rest, the pen is also is not at rest. If we see the reference as the molecules and the particles inside the pen, they are at constant motion. The electrons in this pen, they are at constant motion, but the nucleus is completely at rest. So these are the examples which you have to keep in mind for conceptual clarity. See, 1D motion. In this we will talk about 1D motion. 2D motion is not in your syllabus, and 3D motion is obviously will not be. This 3D motion is not even in the syllabus of class 11th and 12th. So see, when a body moves along straight path like this straight path, a point is moving in straight path, the pen falls, related to a particle, small particle, the pen is falling. So these all are rectilinear motion. The car is moving in one direction, they are moving in one direction. They are 1D motion, all are 1D motion. So in the next video, next part, we will be discussing about the distance and displacement. See, the distance is a scalar quantity, and displacement is a vector quantity. Beforehand I taught you about scalar and vector quantity, so it will be easier for me to explain the distance and displacement part. That's why I told you about the vector and scalar quantity. So see, so I am taking this example so so I can make you understand this all 4 points. All these 4 points I have covered in this through this example. A particle is moving from A to B, but there are 3 paths: path 1, path 2, and path 3. Let the distance between A and B be L. So let's see the path 1 part. The distance is 2 pi L by 2, because see, we are moving in this semicircular path. So the perimeter will be pi r, obviously. So we are 2 pi r by the total circle is this, like this. Perimeter is 2 pi r. So we are moving half of it. We are not moving full perimeter. We are half of it, means pi by 2. So we are moving a distance of pi r. So similarly here r is L by 2. So we are moving pi distance. Sorry, there is a mistake. The distance we are moving is pi L by 2. So I am teaching it another once again. See, the distance we are covering is understand from this. This is r. If it is 2 this is 2r, so this is r. 2 pi r by 2. 2 pi, the total perimeter. We are covering the half part, so 2 pi r by 2. This is pi r. Here I have taken the length L, so that radius will be L by 2. Okay, so the radius is L by 2. So the distance covered is L by 2. But here the displacement magnitude is L. Displacement is the shortest distance from initial and final point. Initial point is A, final point is B. So the distance between A and B is L. We have taken here L. So the displacement magnitude will be L. If anyone asks that what is the direction, then we will say I cap, or towards east, because we have moved from A to B. A to B means each direction or I cap. So in the next part 2, here the distance is equal to the displacement. Why? See, in part 2 A have we move from directly from A to B, so the shortest distance is we are moving in the shortest distance only, so the displacement is equal to distance. We have to keep in mind one thing: displacement is less than or equal to the distance. Displacement can never be greater than distance. In the third part, the distance we covered is L. See the distance L, 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 3L. We covered the distance 3L, but the displacement is still we are moving from A to B. The length is L, so the displacement is L, and displacement is lesser than distance. So hence the point is proved: displacement is greater than, less than or equal to distance. Distance is always positive and can never be zero. See, from A to B we can move like this, then go to B. We can if we don't cover the from distance from A to B, then there is no possibility the distance will be zero. If we move from A to B, there is no possibility, because distance is the path covered, and if you are not covering the path, then how will reach the point B? But in case of displacement, it is a little bit different, because displacement is a vector quantity and vector quantity can be zero. How? Let's take an example. I am taking this example only. We are moving from A to B. First we went from this A to B, then we returned from B to A. So the total displacement will be zero. Total displacement will be zero, because this is initial point and this is initial point. We are moving from the initial point and then returning to the initial point only. So the total displacement is zero, but the total distance is not zero. Total distance is 2L, because we are moving first L then returning L, so 2L. This is the difference between displacement and distance. I hope it will be clear for you. In the next part we will be covering speed and velocity. In this part we will be covering speed and velocity. So let me first read the definition. Velocity is the rate of change of distance with time. Velocity is the velocity is the distance traveled per second by the body in specific direction. So basically speed is the distance by time. The time here we are taking 1 second, so that's why the definition is like that. But for velocity there are two kind of velocity: instantaneous and average velocity. Okay, so and for speed it is also valid: instantaneous and average speed. So the average velocity is displacement's magnitude by time. Why we are taking magnitude? Because see, if I write a vector quantity, this is magnitude, this is direction. So we have only taken the magnitude, means this we have only taken the value of v. This j doesn't carry any value, it's only the direction telling about velocity is upwards, downwards. Here in the circle the velocity is upwards. At this point the velocity is in this direction. Is at this point the velocity is in this direction. At D the velocity is in this direction. So there are two kinds of velocity. Let it before that we complete these 2 points. Speed is always speed is a scalar quantity, and it is a vector quantity. So speed is always positive because it is distance upon time. I have explained previously that distance can never be zero or negative. So this can never be zero and always positive. It can be negative velocity. I am telling why this can be negative. And average velocity can be zero, because displacement can be zero, because I explained this part to you. Displacement can be zero, so the velocity can also be zero. So there are two kinds of velocity: instantaneous and average velocity. Similarly, there are two kinds. Similarly, speed has also instantaneous and average speed. So here we will discuss this part with an example of a circular motion. See, we will be taking points, then we will cover the distance. We will move from A to B. So I have written this. Don't worry about the direction, because the direction part is really advanced and you will not be able to understand that. So I have not included this in this video, but I will add another video where I will tell about the direction, so where to take. Let's see, where directions of the velocity at a different point from, and the average velocity from while moving from this point to this point, and that displacement. So see, we are only taking the magnitude part. At A, we are taking instantaneous speed as v, and it is constant. Instantaneous speed means the speed at a point. Instantaneous speed and average speed, the difference is that if we move from A to B, there are two velocities at if we take the velocity at A, it will differ from B because the magnitude is same, but the directions are not same. At A, the direction of velocity is upwards, and at B, the direction of velocity is westwards, or at this direction. So the velocity is not equal to velocity at A is not equal to velocity at B, but the average velocity means for the displacement upon time. Means we have moved from this point to this point, the displacement, the distance is this, but the displacement is this. See, distance covered is this semicircular quadrant part, arc part, and the displacement is straight line. And from Pythagoras we can find this straight line displacement. See, so this is the difference between instantaneous and average speed. Instantaneous velocity at A is upwards, j cap. I have told you, this is I cap, this is j cap, and this is k cap. Okay. Instantaneous velocity is we have taken instantaneous speed constant, it's not changing. So I am taking this v, instantaneous speed. So the magnitude is v cap, v plus j cap, because it is upwards. This is magnitude, this is direction. From A to B, average speed is the average speed. We will be taking this arc part, this arc part is pi by 4, pi r by 4. Okay, wait a minute, r, sorry, my mistake, my bad. Average speed is pi r by 2 divided by time. We will be taking 1 second for every cases. So the average speed is pi by 2r. Average speed means this distance covered by time. This distance, you will have to remember the formulas of class 8 and 7, also in 9th mathematics, so that you can do this type of sums easily. If you are not good at maths, then you will not be able to be good at science also, physics also. So the instantaneous velocity is v cap, vj cap, and instantaneous speed is v. So the average speed is pi by 2r. See, pi by 2 because r, and the it is a quadrant. You know the formula of quadrant. Leave it. 2 pi r is total 2 pi r is the total perimeter of a circle, and we are taking 1/4 of it. 1/4 means 1 by 4. So pi r by 2 the quadrant. Understand by in this way. Average velocity is displacement by time. Then the magnet, we are taking the magnitude. We are not taking the direction now. So I told you this straight line. So r root 2 is the answer. See, this is not in your syllabus, I know, but I am teaching this for your conceptual clarity. This video is not for every student, I know, but I have already covered the definitions, and the other little bit of little part is left of this chapter. And if you understand the definitions also and the examples which I am telling, then you will be easily able to do your questions in your book. I am taking conscience physics as a reference. Instantaneous velocity, so let's start. Instantaneous velocity at v b. See, at b the velocity, the instantaneous speed is constant. The velocity direction is minus I cap. See, this is I cap, so the opposite direction will obviously be minus I cap. The instantaneous velocity is v minus I cap. The instantaneous speed is v because it is constant, I told you previously. From A to C, see, from A to C, the average velocity is 2r, because see, this is r, this is r. The total displacement is 2r, so 2r by 1 second, so 2r. Average speed is pi r by 1 second, so pi r average speed. Instantaneous velocity at minus j, at c, so it is minus j cap. It is downward. Upwards is j cap, then downwards will be minus j cap. So v minus j cap. Instantaneous speed is constant v. From A to D, it's similar to A to B, but in the direction is there is change in direction. So the instantaneous velocity at D, you know, it is I cap towards this, the v I cap, and this. So A to D, the average velocity is this distance. So r root 2 by Pythagoras theorem, r root 2. Average speed is this quadrant. So we have traveled this. See, we travel this distance. You can leave it. We are taking 2 pi r distance, 1/3 of 2 pi r distance we are covering. So the average speed will be 2 pi r by 3. 1/3, we are taking 1/3 of this distance. Instantaneous, I told you, A to A, the average speed, because it from initial position to have moved to the initial position only, so the displacement is 0. And average speed, this part, so I think I have mistakenly write this. The average speed is not 0. Average speed is 2 pi r by 1 second. So 2 pi r. Neglect it, please. I have mistakenly written this. Average velocity is 0 and average speed is 2 pi r by 1. So see, from this example, it will be problematic for you to understand, so I am explaining it in a shorter way. Instantaneous velocity means we are finding the velocity at a particular point. Average velocity means we are finding the velocity from for a particular instance. We have moved from A to B. We are finding average velocity for A to B.